Alright, you're going to notice that we are jumping up ahead to 11.3 here, and you're going to notice that a lot. We're skipping around, just learning some algebra skills that are going to be showing up in geometry this year. We're going to be working with solving radical equations. This is a fun section about solving equations, and what we're going to be doing is we're going to be squaring both sides. A radical equation is an equation with a variable in the radicand, so it has to be the square root. Something like the square root of x is an example of a radical equation. The variable is underneath the square root. So it's not like this, x root 2. This would not be an example because the x is not underneath the square root. So when you see the square root of a variable, you're going to be using these techniques. And they're actually pretty easy to solve. You're going to treat them like a normal equation. You're going to get the x part by itself first. So in this case, I'm going to get rid of the 8 first, then I'm going to divide by 2, and then the last step is you're just going to square both sides. So in this case, x equals 16. And you can always check your answer by plugging in your answer into the original question. So 2 times the square root of 16 is 4, minus 8. 8 minus 8 equals 0. And there you go. So you can always check your answers, which is important. Let's see. These two problems are pretty much the same, so I'm not going to skip. I'm going to skip that. This one here has got one more step. So I'll show you an example of this here. I'm going to start by subtracting the 12 to get 16. Divide by the 4. So I'm isolating whatever is underneath the square root part. You can't add 7 yet, so don't add 7 yet. Okay? We're going to square both sides here. You get x minus 4 or x minus 7 equals 16. The squaring undoes the square root. And maybe I didn't explain that. But if I have the square root of x and I square it, that's saying the square root of x times the square root of x, which is the square root of x squared, and the square root of x squared is x. So in short, if you square something that's being square rooted, you just get the number itself. You can do this with any number. Take 9, for example, and let's if I square root 9 and then I square 9, so that the square root of 9 would be 3, and then 3 squared is 9. So if you, they're called inverse operations. They undo each other. They give you back the number you start with. So if I take 9, I square root it, and then I square it, I get back 9, the original number. So, and then the last step here is add 7. Now we can add 7. Once you get rid of the square root sign, that's when you can do whatever is underneath. So in this case, it's telling me I need to add 7. I can do that afterwards. Okay, if it has both sides, radicals on both sides, basically if there's two radicals in general, you need to get them to separate sides. But these are actually the easiest problems. All you do is you just square both sides. And it becomes a really easy question. So square both sides, you get rid of the radicals. And then you're going to have to do a little bit of algebra here. Nothing difficult. And there you go. And as always, you could check this by plugging it in. I'm not going to do that though. Alright, there's a question here that I want to show you. It's number 4. Now this one you have two radicals. When this happens, when there's two radicals present, move one to the other side. Like this. There's there and there. So this one here, I'm going to add the root x. Okay, then square. Okay, so now I can square both sides. And you have 4x minus 3 equals x. I'm going to subtract x from both sides. 3x minus 3 equals 0. Add 3, and then divide by 3. X equals 1. So that's the technique. You're going to move one of the roots to the other side, then square it, and you're going to be set up perfectly. I'm not going to talk about extraneous solutions because we don't have the skills to solve those. Here is your assignment. I kept it nice and short for you guys. That is 11.3, which you guys will be using some of these techniques this year. Thank you for tuning in, as always.